This is a light emitting diode. There it's there, that wee red thing. And he's got a wee series resistor beside him to protect him from too much current or voltage. And as its name suggests, a light emitting diode only conducts in one direction, and to connect it the right way round, the triangle on the symbol for the LED points towards the negative terminal of the battery, and then you would connect the other side to the positive terminal of your battery. And we're using the battery pack at 6 volts here, and our red LED is conducting. It's said to be in forward bias. Now, what happens if we connect it the wrong way around? So if I take my LED out, switch it round, and then connect the wires up again, then it does not conduct. It's in reverse bias. Doesn't light up. So an LED only conducts in one direction. Let's put it back the way it should be again. There's it conducting. So the triangle on the LED symbol must be pointing at the negative terminal of the supply. Now let's add another light emitting diode in parallel with the first one, and they're both pointing in the correct direction, both in forward bias. And then when we connect up that green one in parallel with the red one, then they both light up. They're both connected the correct way around. But what happens if we switch one of them round? Let's unplug that green one, switch it round so it's in reverse bias, and the red one is on and the green one is off. Remember, these are both in parallel. They're both in their own individual path here. Red on, green one off. Now what happens if I switch the battery around? If I change the direction of the voltage, or change the direction of the current from the battery, then this time it's the green one that's on and the red one that's off. So changing the direction of the supply changes which of the LEDs is conducting. Now, what happens if we swap our battery pack for an AC power supply? And we can get AC electricity from a lab pack, and we'll set it to 6 volts. And remember, these two LEDs are facing in opposite directions. Look at the symbols on them. Green one facing that way, red one facing the opposite direction. Now the reason I've set this up is because my higher class were doing their homework, and someone in the class said they didn't understand how to do this particular question, which is the same setup with the LEDs in opposite direction with an AC supply. And the last part of the question says the student observes that the red LED is only lit when the ammeter gives a positive reading, and the green LED is only lit when the ammeter gives a negative reading. And we've to explain these observations. And the marking instructions say that the LEDs will only light when they are forward biased, and on the right hand side there it says that one LED will conduct during one half of the cycle and the other LED conducts during the other half of the cycle. And Fraser in my higher class said, I don't get what that means. So I've set it up, and there are the two LEDs with the AC supply on. And they are both on. In fact, they're flashing at 50 times a second, just so you can see it better with the frame rate of the camera. Because the AC supply has got a frequency of 50 Hz. Now we can see that on a CRO. There's the AC signal. And the voltage, and hence the current, is changing direction very, very quickly. Now we can see this better if we go back to our DC supply, the battery pack, and see what happens when the voltage changes direction. So there's our battery pack, and on a CRO, a DC supply is a horizontal straight line, and in this case it's a couple of centimetres above the middle of the screen, and that's showing us a positive voltage in one direction. If we now swap the battery around and plug the wires back in, then we've swapped the direction of the voltage, swapped the direction of the current, and we now get a horizontal straight line a couple of centimetres below the middle of the CRO screen. So when you swap the direction of the voltage, you are switching which one of the LEDs is coming on. Now, I've rigged up this little contraption here, which allows me to change the direction of the DC supply by turning this wee handle here. And then if we look and see what happens as I turn the handle, just now that green LED is on, but when I turn the handle, then it switches to the red LED, switches back to the green, switches back to the red one again. And so we're switching the direction of the voltage and hence the current just by turning this little handle. We're simulating a kind of slow version of AC electricity. And if we look at the CRO, you see the spot moves up, back to the middle, moves down, back to the middle. So the voltage is going positive and then negative. Positive when it's moving up, and then opposite direction negative when it's going down. So changing the direction of the voltage will change which of the LEDs is lighting up. So one of the LEDs lights for one half cycle, the other one lights for the other half cycle. And finally, if I make the spot on the CRO move horizontally across the screen, then you can see that it traces out a sine wave when I turn the handle, and the LEDs are flashing. And then when we go back to our AC power supply with a frequency of 50 Hz, then one LED is conducting for one half cycle, the other LED for the other half cycle. There you go then.